This vodcast is about solving trigonometric equations using arc relations, and this one is going to be an arc sine problem. So we're going to start off by doing a bunch of algebra to isolate the sine function. So we subtract 6 from both sides, and you get negative 4 equals 5 sine. I'm using square brackets here to make sure you're realizing that all this stuff is part of the sine function. Then we divide by 5 and we get negative 4/5 or negative 0.8 sine 20 theta minus 30. So now we've got the sine function isolated. The operation that undoes sine is arc sine. So we take the arc sine of both sides. Arc sine of negative 4/5. Take the arc sine of the right hand side and we're left with the stuff inside, and we get theta minus 30. Let's do some more algebra and we're going to try and isolate theta. That's what we're really after. So we multiply both sides by 1/20th arc sine of negative 4/5 and get theta minus 30, and then we add 30 to both sides and we have 30 plus 1/20 arc sine of negative 4/5. Finally, we've isolated theta, but we have this arc sine thing in the middle of the equation, and we want to be able to substitute for that. So now we're going to do a little sidebar here. Here's the UV plane. Here's about where negative 4/5 would be, let's say. Now let's do it this way. Let me draw in my angles. They're going to be in the third and fourth quadrants because that is where sine is negative. I could draw in a reference triangle, like this side could be negative 4 and the hypotenuse could be 5, and this could be negative 4 and this could be 5. And what I'm interested in is this angle and some expression for this angle in the third quadrant. I need them both. And the way I'm going to start doing that is by taking the inverse sine of negative 4/5. That is negative 53.1 degrees. Negative 53.1 degrees. And in quadrant 3, that would be 180 minus that thing, which is 233. Yes, that is a third quadrant angle. I recognize it, 233.1 degrees. So my general solution for the arc sine of negative 4/5 are these two things. Negative 53.1 plus 360n, that's everything coterminal with negative 53.1. And 233.1 plus 360n, that's everything that would, every angle with that sine value in the third quadrant. Those are the things I'm going to substitute in for arc sine. So I'm going to rewrite this seeing theta is equal to 30 plus 1/20th times negative 53.1 plus 360n. I just substitute, that's the fourth quadrant angle substituted in there, and here's this third quadrant angle plus 120 over, I have to do this as two separate equations, 233.1 plus 360n. Now there's some more distributing and arithmetic to get the final general solution. So we're going to do negative 53.1 divided by, negative 53.1 divided by 20 is negative 2.655. 30 minus 2.655, that's in there like that, distributed, and then make sure you distribute that. That's going to be 18 plus 18n, and then of course 30 minus 2.65, that can be simplified. So I can just add 30 to this, get what I want, I think, 27.345. 27.345 plus 18n. That is one branch of the principle of the general solution. Then let's do this again over here for 233.1 divided by 20. That's 11.655. 30 plus 11.655 plus, again, make sure you distribute, 18n. And that's going to be what, 41.655 plus 18n. So I'm going to write, here's the general solution for theta. Theta is equal to 27.345 plus 18n and 41.655 plus 18n. Now let's go back to the beginning of the equation, see if of the problem, see if I'm done. That's my general solution, but I was supposed to find it for values of theta between 0 and 40. So my particular solutions, theta is equal to, let's see, well, if I let n equal 0, 27.345, that's between 0 and 40. This one's not between 0 and 40 at all. But if I add, let's see, 27.345, if I add 18 to that when n is equal to 1, not too big. How about 41.655 when I subtract 18? Is that a particular value that I want? 23.655. 23.655. How about if I subtract 18 again? Yeah, 5.655. 5.655. How about if I subtract 27.345? That's when n is equal to -1, so minus 18. And I got 9.345. 9.345. Now if I subtract 18 again, they're going to be negative, and I don't want those. So that's the general solution. And then with particular solutions. Okay, now I'm going to check those. In fact, let me plug this equation into my calculator. Just the right-hand side here. Six plus 5 sine 20. And what were those solutions? Let me just try one of them here. How about 9.345? Minus 30. Might have too many parentheses in there. Oh, that's 2. Oh, that's close enough. I got some round off error, but that looks like it's a good solution. Now you might want to check more than that. We'll talk more about in class using second calc intersect on your calculator to do more checks that are even a little bit better way to do it. But that's it. Thanks for watching.